some molarity problems and dilution also. So let's read the question. First one, how many grams of sucrose are in a 250 milliliters of 3.2 molar solution? Okay, so now the question is how many grams do we have in a particular solution. So which means using our formula, molarity is equal to moles over liter. Now we actually will have to first find the moles. Okay, find moles and then mass. Okay, from there. So we will need the formula mass of C12H22O11. So let's go ahead and do that first. So C12H22O11, that is equal to 342.022 grams per mole. Okay, and that is 12 carbon plus 22 hydrogens and 11 oxygens. You add them up together, that's what you get. So then we're going to go ahead and do cross multiplication over here. So remember, molarity is moles over liter, so moles is equal to molarity times liter, which then molarity is 3.2 moles over liter times liters, which is 0.250 liters. Okay, convert the 250 milliliters into liters and always write your molarity here as moles per liter, so you can cancel out the liters then, and then you'll be left with moles, and this calculation should give you 0.8 moles. And so this is the number of moles of sucrose we have. Now we just need to go ahead and convert the moles of sucrose into grams of sucrose, which is then 342.022 grams in 1 mole of sucrose, and that gives us a wonderful number of 273.6 grams. Okay, so that's our answer. You can go ahead and round that off to 2 significant figures if you want to, so that would be equal to 270 grams, okay, if you want. Okay. Next problem, how many milliliters of 0.0886 molar solution of sucrose has 35.4 milligrams of sucrose, okay, in it? So now the question is actually about milliliters, okay, and so I chose sucrose again, so I won't have to worry about calculating the mass, okay, of sucrose, but we have it, okay, over here. So in any case, let's start again. Our problem always starts with molarity is moles over liters. Now what we're going to find out is, of course, the liters, okay. So molarity is moles over liters, and therefore liters is moles divided by molarity. And again, remember, molarity is moles over liters. Okay, so what we'll do is, since we're supposed to find milliliters, okay, let's do that, but then we also need moles. Okay, so to calculate the moles, all right, we need to use the 35.4 milligram first. Okay, so then let's go ahead and do that. 35.4 milligram, which we need to convert to grams first. So in 1 gram we have 1000 milligram, okay, of sucrose, and in 1 mole of sucrose we have 342.022 grams of sucrose, and this gives us 1.035 times 10 to the negative 4 moles. Okay, so this is the moles that we need for the top portion here. Okay, so now liters is equal to 1.035 times 10 to the negative 4 moles, and then the molarity, divide that by the molarity, which is 0.0886 moles per liter. Okay, and that's how the moles get cancelled, and the liters is 1 over 1 over 1, so the liters will go up on the top, and our final answer is 0.001168 liters. And if you want to convert that into the right sig figs, it is equivalent to 0.001117 liters. Okay, and if you need to convert that into milliliters, you multiply that by 1,000, okay, times 1,000, and that should give us 1.17 milliliters. Okay, final answer. So step number 1, okay, over here. Step number 2, convert that into liters, all right, and finally milliliters there. Okay, next problem is a little bit different about molarity. How many milliliters of 1 butanol, and this is the formula given to you, C4H10O, with the density of 0.810 grams per milliliter, are required to make 725 milliliters of 0.350 molar solution. Okay, so these are our numbers that we will need. So this question is, how many milliliters of 1 butanol do you need? So 1 butanol is a liquid, and since we are asked to make a solution, all right, and the molarity is given to us, we still need to find moles. Okay, so find moles, convert to grams, and then convert to liters, okay, or milliliters. And this will be, of course, using density, okay, because butanol is a liquid. Okay, so far we've worked with solids, and solids have grams, but this one is a liquid. All right, so we can start anywhere, okay, that we want, but we'll start right here with the moles. Okay, so molarity again is moles over liter. We need to find moles, so that's equal to molarity times liter, which is 0.350 moles over liter times the volume, which is 0.725 liters. And remember again, okay, convert it into liters, so you have the same units. Okay, and then this is equal to 0.25375 moles. Okay, so that is our first step that we did. Now that we have the moles, okay, from moles we have to convert this into grams. So step number 2, or let me say step number B. Okay, so this was A. In step number B, we will take 0.25375 moles of butanol and convert that into grams. So in 1 mole of C4H10O, there are 74.034 grams, and remember this is molecular weight, okay, of the butanol. Once we have the grams, okay, then we have to convert that into density. Okay, but I'm going to stop over here for a second and then do that in the next step. So we have 18.786 grams of butanol. So just a little step here. If you were trying to weigh this out and make this using a scale, a balance, then you would weigh out 18.786 grams of butanol and dissolve it in 725 milliliters of water. But we're not doing that. Okay, we need to have milliliters so that we can use a graduated cylinder instead of actually using a balance. All right, so then our last step, which is C, is using the density. Density is mass over volume. We are asked to figure out volume, so that is mass over density, and the mass that we have is 18.786 grams, and density is given to us in the problem, which is 0.810 grams per milliliters. Okay, so grams get cancelled out, you're left with milliliters, and that is then 23.2 milliliters of butanol. Okay, that's what you need. So we need to take 23.2 milliliters of butanol, make it up to 725 milliliters. Okay, of water. All right, so you don't add 725, you make it up to 725 milliliters. And that will give you 0.350 molar of solution. Okay, one last problem on this page, and that is for dilution. Dilution problems are really quite straightforward, provided that you put your right numbers on the right side. Okay, so the question is, how many milliliters of a 2.00 molar copper 2 sulfate stock solution are needed to make 0.250 liters of 0.400 molar copper 2 sulfate solution? So how many milliliters of a 2.00 molar solution of copper sulfate are required to make 0.250 liters of 0.400 molar copper sulfate solution? So make sure you keep your numbers together. So the diluted solution is on the right hand side for me and the concentrated is on the left. Of course, we will not get milliliters in this case because our units here are liters, but that doesn't matter. We'll work on that later. So I will write liters over here instead of milliliters so that we don't get confused. 0.250 liters times 0.400 molarity divided by 2.00 molarity. Okay, and that gives us 0.050 liters, which now we can convert to milliliters. Okay, so multiplied by 1000, and that's equal to 50.00 milliliters. So what does this mean? That you take 50.00 milliliters of 2.00 molar copper sulfate and add enough water to make up to 0.250 liters. So you don't add 250 milliliters of water, you actually make it up to 250 milliliters of solution. Okay.